Hi everybody, Ms. Lee here. We're going to talk about some trig today. And so we're going to talk about some things that are old that you should have already learned in geometry, and then we're going to talk about some new things that we're learning today. Okay, so your basic trig functions, there's three basic trig functions that you know. There's sine of theta, cosine of theta, and tangent of theta. These are the ones that you already know. And your geometry teacher may have taught you the mnemonic SOHCAHTOA. SOHCAHTOA is just so for SOH, ka for CAH, and then TOA for TOA. Oops, A. Okay, so ultimately, sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And you should already know this, but if you don't know what opposite and adjacent sort of mean, what this means is we're in a right triangle and you have some angle theta. And so the hypotenuse is generally always going to be the longest side or the side opposite of the right triangle, or sorry, of the right angle. So this is the hypotenuse. And then, of course, the side opposite the angle that we're talking about here. So theta is the angle that we're taking the sine of over here, cosine of this angle, and then tangent of this angle over here. So opposite is the side opposite. So opposite. And then adjacent is the side next to it. So adjacent right here. Okay, so I'm going to go ahead and highlight these accordingly. Oopsies. I'm going to highlight these accordingly so that you can have your notes be color-coded. So if you want to highlight along with me, I'm going to go ahead and highlight the angle as theta. Okay, so when you write sine, cosine, and tangent, we write them as sine of theta or cosine of theta. So sine and cosine and tangent do not go by themselves ever. So there's no such thing as dividing a sine. Sine is not an entity. Sine is not a thing. You cannot divide by sine. You can do the sine inverse, but always have a theta with your sine. So do not write sine by itself. Write sine of theta always. Okay, we'll go ahead and highlight the opposite in purple. So opposite means this entire side length right here. Okay, so that's what we're going to go ahead and highlight in purple. We'll do adjacent in pink. So again, adjacent is going to be this entire side length right here. So this is adjacent. And we're going to do hypotenuse in blue. So the hypotenuse is this entire side length right here. Okay. And just to like write in parentheses, adjacent, we shorten as A, opposite, we shorten as O, and the hypotenuse, we shorten as H. Okay. So this brings us to the reciprocal trig functions. And so there's three of these. And so reciprocal, if you remember from elementary school, that's basically the flipping of the original. So you have a flip of each of these, and that takes us to our reciprocal functions. Okay, so there's cosecant of theta, which is equal to 1 over sine of theta. So the flip of sine is going to be h over o. Okay, so again, we're going to go ahead and highlight accordingly. And just to spell that out for you, cosecant is spelled as C-O-S-E-C-A-N-T. Okay, cosecant. Then we have secant for cosine. So secant theta is 1 over cosine of theta. And this is the flip of A over H, so then it would be H over A. Okay, and just to spell that out for you, that's S-E-C-A-N-T, secant. Okay, so secant of theta is equal to 1 over cosine of theta, which is equivalent to hypotenuse over adjacent, which is the flip of cosine. So I'm sure you can guess what the last one is going to be. The last one is cotangent. So cotangent of theta equals 1 over tangent of theta, which equals adjacent over opposites. So the flip of tangent, of course. Okay, so we're going to go ahead and solve the following right triangle as an example. We're going to find all of the missing sides and angles, and then we're going to find the values of the 6 trig functions for theta. Okay, so first things first, we're going to go ahead and find this side length over here. So with that, we do Pythagorean theorem. So since these are each the legs, we do 30 squared plus 16 squared equals, and then c squared. So then c is going to equal the square root of, and then we'll do that on our calculators. So we have 30 squared plus 16 squared. So square root of 1156, which is 34. Okay, so this side length is going to be 34. And this is also going to be the hypotenuse. So we'll go ahead and color code this with our example drawing. So the adjacent to theta is the one next to the theta. So that would be 30. And then the opposite to theta would be 16. Okay, so let's go ahead and do each of our trig values. So sine of theta, that's opposite over hypotenuse. So that's 16 over 34. Which if you simplify that, that's going to be 8 over 17. Cosine of theta, that would be adjacent over hypotenuse, so that's 30 over 34. And again, that simplifies to 15 over 17. And so tangent of theta, we do opposite over adjacent, that's 16 over 30. And again, that simplifies to 8 over 15. Cosecant, we can just go ahead and take the flip of the sign, so that's 17 over 8. Secant, we can do the flip of cosine, so that's 17 over 15. And then cotangent, we do the flip of 8 over 15, so that's 15 over 8. Okay, so if we want to figure out what theta is, we can just do the inverse of one of these three on our calculator. And so we'll go ahead and put it in degree mode. So we'll take our calculator, we press mode, and then we switch over to degree mode. And so if you know sine of theta is 8 over 17, we want to do the inverse of that. So we do sine inverse of, and then 8 over 17. And that'll give us the approximate angle, which is 28.072. So in my class degrees, so in my class, we want to round to the third decimal place always. Okay, so those are your 6 basic trig functions and reciprocal functions. And you should now be able to evaluate each of the 6 trig functions given a right triangle. Go ahead and try some of the examples, and I'll see you in the next video. Happy day.